And in this video, we're going to look at some of the applications of right-angled trigonometry. We talk about angles of elevation and angles of depression. Basically, if you look towards the horizontal, right, towards the horizon perhaps, if there's an object way up here, then the angle between the horizontal and the line in which you would have to look at would be called the angle of elevation. It's how much you'd have to lift your head, if you like. If you're up high somewhere and you're looking towards the horizontal and you then have to kind of look down, that's called an angle of depression instead. In example 5, we have is a cliff, right? So perhaps we're at the sea. This is the sea down here. There's a boat on the sea. The cliff is 120 meters tall. And we're told that the angle of depression, so the angle between the horizontal and the angle and the line that we'd have to look along to see the boat, is 5 degrees. So this is our drawing. We're up here somewhere, we're at the cliff top, we're looking down towards the boat. Now the fact that this is parallel to this, right, that the sea is horizontal and so is the line that we have to compare things with, the horizontal is always the one that we look at, allows us to say that this angle here and this angle here are the same. They're alternate angles. If this is 5 degrees, then this is 5 degrees. So we now have a triangle with some information about it. We're told that this angle here is 5 degrees, that the cliff is 120 degrees, and we're asked how far away is the ship, the boat, from the cliff. So we're asked what x is equal to. So we just use our SOHCAHTOA for this. This side here, relative to this angle, is opposite. It's opposite the 5. The x is adjacent to the 5. It's next to the 5. And this side here we don't really care about, is the hypotenuse. So we're interested in the opposite and the adjacent. Which one is the opposite and adjacent? It's not sine, that's opposite and hypotenuse. It's not cosine, that's adjacent and hypotenuse. So it's tangent, opposite and adjacent, TOA. So we set up an equation now. We set up something that says that the tan of 5 degrees is going to be equal to 120 over x. And then our job is just to try to solve that. Right? So we can rearrange that by multiplying both sides by x. You can then divide both sides by tan of 5 degrees. Tan of 5 degrees is just a number that you can get on your calculator. And if you do that, your x should be roughly 1,370 meters. Now here's a much more difficult question, and this is tricky, but it's a kind of application that allows people to do things like find the distance between stars and things like that. What we've got here is a building, and our job is going to be to try to figure out the height of this building. Unfortunately, we don't really have the side of the triangle. Right? We've got various bits of information. We've got partial information about this big triangle, partial information about this small triangle. So we're going to have to use some special techniques to solve this. First of all, with the small triangle, let's set up an equation. We're going to have the opposite over the adjacent, in other words, the h divided by the x equal to tan of 4 degrees. Okay, so in this case, that's going to give us this equation here. And we can rearrange that equation a little bit like this. Right? Just rearranging it for x. If we look now at the bigger triangle, this triangle here, Now, we've got the 3 degrees as our angle. The h is still the opposite, it's opposite the 3 degrees. And this side here, the 30 plus x, is our adjacent. So if we set up an equation from this big triangle, it's going to be, instead of tan of 4 degrees, it's going to be tan of 3 degrees equals the opposite, which is h, divided by 30 plus x. And again, we can rearrange that equation a little bit. If we rearrange it, for x, it'll look like this. Now, you can then we can equate equation 1 and equation 2, because they're both expressions for x. And if we do that, we get this equation. It's just making this equal to this, because they're both equal to the same thing, they're both equal to x. And then our job is then to try and rearrange this thing so that we can find out what h is. So the next step would be to take the 30 to one side and take everything that involves the h to the other side. We can then take h out as a factor, and that's what's happened here. And then we can rearrange this so that we get this equation here. H is equal to 30 divided by this whole big long expression here. There's some kind of more complicated things that have happened here, but what we get in the end should be this expression, 30 tan 3 tan 4 divided by tan 4 minus tan 3. It's basically just 30. It's basically just the 30 divided by this expression here, and that gives us 6.28.